Welcome back. So now we're going to talk about the quotient rule this time, and I want to tie it into the product rule. This is what I showed you in our last video. Okay, this was the format I was writing it in. And well, let's tie it in with the quotient rule. Here's the quotient rule, and when written in this format here, it looks like the numerator of the quotient rule. You have f prime times g, f prime times g. You have g prime times f, you have g prime times f. The only difference is the product rule, you're adding those two, and in the quotient rule, you're subtracting those two. So that's really the reason why I memorized that. It kind of always helped me memorize the quotient rule. Let's see what this tells us. So the quotient, so f divided by g, so we have a rational function. We have a polynomial upstairs and downstairs. If those two are differentiable, then that function is also differentiable. We've talked about the meaning of those. They specify g of x cannot be 0. Why? I think you know why, okay? We've talked about that in class many times. A 0 in the denominator makes your function undefined. So that's why it makes that extra statement right here. Let's write this down here. So that's the product rule. So the quotient rule, if I follow the same notation as above here, if I have some sort of function y, now instead of f times g, I'm looking for f divided by g, but we're going to take the derivative of that. Well, actually, hold on. That's what the y would be, and then if we want to take the derivative of that, the notation would look like this. And now, instead of doing this for the product rule, we are going to follow this. And the only difference I do is, again, I write it like this. So I write f prime times g minus f g prime. And if you notice, that's mathematically equivalent to the numerator right here. And then we have ourselves g squared. I wrote it without the independent variable, all right? With the x, without the x, means the same thing. And, well, let's do some examples now. Before we do this problem, I just want to take a moment to remind everyone of the different notations because I'm using them interchangeably. I want to make sure you remember they are all mathematically equivalent depending on what function you're using. You're also going to see later on in the year, and I might just do it in class, instead of f of x, how about y of x? Well, you already know what function notation is, so y prime of x. The benefit of having that independent variable there is it tells you what to plug in. So if I tell you y prime of 4, you know you're not plugging in x equals 2. These are all mathematically equivalent. Okay, just a general reminder before we continue. Here is the quotient rule. That is what I did before. Now we are going to do this example. Given the function f of x, we're going to find f prime of x in simplified form. Now, simplified form, I'll show you what Delta Math means by simplified form. Well, this is a quotient, right? We have ourselves a fraction. So this right here, I know this is f of x, but it's a y function, right? Anyway, right there, that's also a y function. But the reason why I want to think of this as y is we're going to treat the f as your numerator, and we're going to treat g as your denominator, so keep that in mind. And so to use that last notation that I had right over here in this corner, if I want to find the derivative of my function with respect to x, okay, the brackets or the parentheses, same thing. Well, you would write it like this. This is the derivative of x over 1 minus 4x cubed, and we're going to take the derivative of that function with respect to x. Okay? This is what it would look like. So f prime, well, the derivative of x is 1. We're going to leave the second one, which is the denominator. Minus, not plus here. Now we leave the x, and we take the derivative of the denominator. 1 becomes 0. This term right here becomes negative 12x squared. The denominator, we take that, and we square it. Now the numerator, you see, we can clean this numerator we can clean up a little bit. So let's do that. 1 times anything is itself, so that's just 1 minus 4x cubed. And here when I multiply those two, that's a positive 12, and then I have x cubed all over this. Notice here there's another combination we can combine these two right here. So let's finish this up. Let me move that up a bit. And here we go. We have 1 plus 8x cubed all over 1 minus 4x cubed squared. And right there is you're done. Simplest form, what a lot of you are going to want to do is this. You see this and you might want to multiply it out, 1 minus 4x cubed times itself. But remember, delta math is saying simplified form. So simplified form is leaving these factors like this, okay? Just leaving it this times itself squared. You're done. Let's try this one now. Given the function y, we have to find dy dx in simplified form. All right, so there's our function. What makes me think of the quotient rule? Well, it's a fraction. I have a numerator and a denominator. That's a quotient. That's what makes me think of it. Let's go on. Let's continue. We have dy dx, or y prime. It all means the same thing. I'll call it dy dx now. Well, we're going to take remember, this is the f, and this is the g. So first you take the derivative of the first, which becomes 2x. You leave the second. Minus. Now we leave the first one, the numerator. And we take the derivative of the denominator, which in this case just becomes 1. Don't forget about your denominator. It is g squared. What was g? X plus 5. Now, before I combine my like terms, this is simplified form, the denominator. Don't multiply that out. Just combine your like terms and stop. First, we're going to do this, distribute the 2x. Then we're going to distribute the negative. Well, before I do that, I should multiply by the 1 here, but 1 times anything is itself, so that's just going to become, let's see, 2x squared plus 10x minus 2 minus x squared. There's your numerator. Let's combine our like terms, and then we're done. Okay, there we go. Let's see what we got here. So this is an x squared, and that's an x squared. So let's combine those, and we have 1x squared plus 10x minus 2 all over this squared. That is simplified form once you combine your like terms upstairs. And please remember that you're watching a video. If I'm going too fast at any point, just, pause it for a second, copy down, get caught up, okay? Great. Well, on to the next example now. All right, let's do one more example together, and then it's your turn. You're on your own, so good luck. Here we are, f of x. We have to find f prime of x, and we're going to leave it in simplified form. Maybe it would help if I label these. I think you get the idea, but f is what I'm referring to as the numerator, and the g is the function down in the denominator. So let's do it. The first one becomes 4x, right? If we take the derivative of this one, that becomes 4x, and we leave, we leave the second, which is 3 plus 4x squared. Minus, I leave the 2x squared plus 1, and we take the derivative of the denominator to this one. That's 3 becomes 0, and 8x squared. I'm sorry, 8x. You have to reduce the exponent by 1. Divided by g squared. G is your denominator. And let's see if we can clean this up a little bit. Remember simplified form, we're not going to multiply that out. We're just going to leave 3 plus 4x squared alone. And then what do we get here? That's 12x, 16x cubed. And before we do that, let's multiply this. That's going to be 16x cubed, but there's a negative, so it's negative 16x cubed. Now we do this one. 1 times 8x is 8x, but there's a negative. It's negative 8x. This right here is going to equal, let's combine our like terms. We have, these two cancel. Look at that. We have a 12x minus an 8x. That's 4x. Is there anything else we can do? I don't think so. I'm going to say that's our final answer.